In the past couple of exercises, we've been looking at interest. Interest is what your money earns. In the next two exercises, we're going to be looking at depreciation, and that is the amount that your money loses, or the value of something that you own becomes less. And there's two types of depreciation: flat rate depreciation and reducing balance depreciation. Let's start with flat rate depreciation. That is the opposite, if you like, to simple interest. Simple interest was going up by a constant amount. Well, with flat rate depreciation, we are going down by a fixed amount. So a couple of terms that we do need to be familiar with for both types of depreciation. Well, we've just talked about the fact that depreciation is a decrease in value of something. Okay, well, the other term, book value. Now, book value is the value of something at a particular time in its life. So if you think about something that you've bought, perhaps your earpods or your AirPods, after 2 years, the book value of that would be a lot less than the purchase price, the price that you paid for them. And then if you think about scrap value, they are going to get to a point where they're not worth a lot. They might still be working, but they're not worth anything to sell them off to anybody. And therefore, the effective life of something is the amount of time that it's in use. So if you think about a smartphone, the effective life of most smartphones is probably about 4, maybe 5 years, depending on whether you change the battery. But these are terms that we need to be on top of for the next two exercises. So flat rate depreciation. Let's have a look at the rule for it. D is equal to PRT on 100. Does that look familiar to you? Well, it should. Remember the rule for simple interest, I equals PRT on 100. So interest is adding on to your principal, but depreciation is taking away from your principal, or if you like, taking away from your purchase price. And so we know this amount now as our book value. And so therefore book value is equal to the purchase price, the amount you paid, minus the amount that it depreciates, PRT on 100. Julie purchases a new motorbike for $24,000. It decreases by 10% of the purchase price each year. So remember, anything that you buy brand new, like a car, once you take it out of the car yard, it immediately starts to depreciate. So this motorbike is depreciating by 10% of the purchase price each year. So 10% of the purchase price is a flat rate amount, isn't it? So here we can see that the purchase price is $24,000. So writing out everything that you know, the rate that it depreciates by is 10%. And we're talking about each year. So T is equal to 1. All right, so how much does it depreciate annually? That is for 1 year. And what are we looking for here? We are looking for the amount of annual depreciation. So therefore, we are looking for D. What was our rule again? D is equal to PRT over 100. So the depreciation here would be 24,000 times the rate, which is 10, times by 1, because it's for 1 year, all over 100. Pop that into your calculator, or you solve. Remember, we use solve for simple interest, and you get $2,400. So that's how much it depreciates each year. So if it depreciates at a constant rate, the same amount every year, and the next question says, what is the amount of depreciation after 4 years? It would be 4 lots of 2,400. We could have used our rule And instead for T, we could have put in 4 rather than 1 because it was for 4 years. But because we already knew what it was for 1 year, this is just as easy. So therefore, what do we get when we multiply that out? That is $9,600 after 4 years. So the question says, what is the book value after 4 years? The book value. Remember, the book value is the price that it's worth then. So the book value after 4 years is equal to, what did you pay for it? You paid $24,000 for the bike. And after 4 years, it depreciated $9,600. So what is the bike now worth after 4 years? It is only worth $14,400. So that's a lot of money that it's depreciated in a 4-year period. Now, remember, this is the same as simple interest. Simple interest was a positive straight line graph, positive straight line relationship. The only difference with flat rate depreciation, it's going to be straight line, but it's actually going to be a negative straight line relationship. In this example, a factory manager says that a tractor purchased for $30,000 has a useful life of 10 years. Its scrap value, remember its value at the end of its life, is $6,000. So what is the annual amount of depreciation? Well, we don't have a rate here, but that doesn't mean that we can't work out how much it depreciates each year. So what we're going to work out is, first of all, what the total depreciation is. And that's pretty easy because we know that it was $30,000. That was the purchase price. And in the end, it was only worth $6,000, which would mean that it had depreciated $24,000. So in 10 years, it's depreciated $24,000. Now remember, it goes down by the same amount every year. So therefore, the depreciation in 1 year would be that total amount, which was $24,000, divided by the 10 years that it took to get to $6,000, and that gives you $2,400. So that's how much it's depreciating each year. $24,000 for the 10 years, $2,400 per year. Per year. That's important. Part B asks us, what is the flat rate? So we're looking for the rate here. How do we work out the rate? Well, the easy answer there, it is the amount of the annual depreciation expressed as a percentage of the original purchase price. So in this case, the annual depreciation is $2,400. The original price was $30,000. And then we are going to times it by 100 because we want it as a percentage, or 100 over 1. And when you work that out, that comes out to be 8%. So that is what your R is equal to. Create a table for book value and time, and hence draw a graph, book value versus time. Now, this is something that we will be able to do on our calculator as well as manually. So looking at it manually here, we know that when time is 0, the book value, or the price of the tractor, is $30,000. After 1 year, it's depreciated $2,400. So it's $30,000, take away $2,400, which gives us $27,600. So let's keep going. When we have 2 years, it's depreciated to $25,200. After 3 years, it's depreciated to $22,800. After 4 years, it goes to $20,400. After 5 years, it goes down to $18,000. So I want to keep going down as far as the book value. So 6 years, we're up to, it's depreciated by 15,000. Sorry, the book value is 15,600. After 7 years, it is 13,200. After 8 years, its book value now is $10,800. 9 years, the book value is 8,400. And of course, we knew that after 10 years, the scrap value is $6,000. Now there's the graph of book value versus time. I've put 3 of the points in there, but realistically all of these values in my table are on that graph, and you should probably include them in your graph when you are plotting it as well. But you can see it is a negative straight line relationship.